Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series meant for the BSc Physical Sciences students who are doing the paper on applied electronics. We are now going through the section on nuclear physics. In the sense, we go through the unit 4, which has the title radioactivity, which contains natural radioactivity, artificial radioactivity, and so on. The title of the talk is natural radioactivity. The contents of this lecture are discovery of radioactivity, 3 kinds of radiations, examples, positron. And first of all, when we talk about discovery of radioactivity, you should know that the natural radioactivity is there, and also we have got artificial radioactivity. And before I start natural radioactivity as well as artificial radioactivity, I should tell you, so far we have been discussing about electrons which are found outside the nucleus. Hereafter, in the lectures to come, we will be talking about certain nuclear processes, and this section on radioactivity is of immense importance as it is applied in very many fields. For instance, you have heard of cobalt therapy, which is used to cure cancer, and so it has got wide ranging applications. So, science and its development is a continuous process. This is a continuation of what Röntgen discovered with regard to X-rays. So, natural radioactivity is activity existing in nature, spontaneous emission of particles or electromagnetic radiation, or both from an unstable nucleus. It is labeled as radioactivity. The important point is, any nucleus which is unstable, with the mass number, what is mass number? The number of protons and the number of neutrons, that is called the mass number. You know, the number of protons and number of neutrons will not be equal to one another after certain nuclear mass. The number of neutrons will be larger rather than the number of protons, and of course, you all know that the atom should be neutral. Therefore, the number of protons will be equal to the number of electrons in any atom, but the number of neutrons need not be or will not be equal to the number of protons. And with regard to natural radioactivity, I should tell you, whenever you got an unstable nucleus, it will spontaneously emit the following kinds of radiation, namely alpha particle, beta particles and gamma rays. Now, we should know what are the nuclei which will emit this kind of radiations, and how to know the nature of the particles, what is alpha particle, what is beta particle and what are gamma rays. Gamma rays, of course, you would have studied even in high school. It is a part of the electromagnetic spectrum. The credit for finding or discovering the natural radioactivity goes to Henry Becquerel. So, in 1903, Becquerel shared the Nobel Prize in physics with Pierre Curie and Marie Curie in recognition of the extraordinary services they have rendered by the discovery of spontaneous radioactivity. In fact, the spontaneous radioactivity was discovered by Becquerel, Henry Becquerel, and of course, the other things like polonium. What is polonium? How do you get the name polonium? Polonium is from Poland, because that is the birthplace of Marie Curie. So, polonium and radium, they were discovered by the Curies. So, the 1903 Nobel Prize went to the three people, Henry Becquerel, Madame Curie and her husband Pierre Curie. The most important thing to be known by the young people is that the first lady to get the Nobel Prize is Madame Curie. There is a prize that was given to her in 1903, the Nobel Prize in Physics. She got yet another prize, Nobel Prize in Chemistry, in her later years. Therefore, the only woman, she is an enigmatic figure, the only woman to get Nobel Prize twice, first in the field of physics and then in the field of chemistry. Those days things were difficult. She was not given recognition, the proper recognition for being a lady. In a meeting which is held in London, both the husband and wife were invited, but she was refused to give the talk on her work because she was a lady. That is the way in which the gender difference, that is the way in which the lady scientists were treated those days. Now things are changing, and there are a number of Nobel laureates now among the ladies. So, Marie Curie and Pierre Curie, in recognition of their work, you got several stamps. You got the Pierre Curie here, Madame Curie here. As I told you, Madame Curie says, I am one of those who think like Nobel. Who is Nobel? The prize is named after Nobel, Alfred Nobel, the Nobel Prize. That humanity will draw more good than evil from the new discoveries. The new discoveries should give new things, I mean, which are helpful to humanity. The atom bomb can be used for any purpose, the atomic energy for power generation. Similarly, radioactivity for curing cancer. Of course, many people may be knowing or may not be knowing the fact that Curie, almost she died of cancer, because those days when she was handling the radioactive isotopes, when we talk of alpha particle, beta particle, gamma radiation and all, these are coming from heavy nuclei, the radioactivity is coming. She was unaware of the ill effects, the bad effects or the side effects of radioactivity. So, she was carrying along with her radium without knowing that it will be harmful to the human system. So, she died of cancer, but the same cobalt or other radioactive substances are nowadays used in plenty with great care to cure cancer. The one that causes cancer can also be used to cure cancer. So, it is a double edged weapon. Here is Pierre Curie, the Madame Curie, the husband and wife, they along with Henry Becquerel share the first Nobel Prize. As I told you at the beginning, it is an important thing in the history of physics, namely the discovery of X-rays by Röntgen, and it is a very interesting thing. On the day February 26 of 1896, Becquerel observed certain images on a photographic plate. Here comes the story. A photographic plate made by Henry Becquerel shows the effects of exposure to radioactivity. This is coming from radioactivity. A metal Maltese cross placed between the plate and radioactive uranium salt left a clearly visible shadow on the plate. You have a shadow on the plate. In 1896, Henry Becquerel was using naturally fluorescent minerals to study the properties of X-rays. So, as I told you, the discovery of X-rays, the credit goes to Röntgen. What Becquerel was interested, now all of you should know that most of the discoveries have been accidental. This is again an accidental discovery which was made by Becquerel. He was using naturally fluorescent minerals to study the properties of X-rays. So, his intention was to study the properties of X-rays. He exposed potassium uranyl sulfate, the uranium sulfates, right, to sunlight, and then placed it on the photographic plates wrapped in black paper, believing that the uranium absorbed sun's energy and then emitted it as X-rays. He believed that uranium absorbed sun's energy and then it emitted X-rays. So, he was expecting the radiation which is coming out should be like X-rays, should be X-rays. The hypothesis was disproved on 26th and 27th of February, when his experiment failed because it was overcast in Paris. There is no sun. In spite of the fact that there is no sun, only when there is sun you should be getting X-rays. This is what is told in the paragraph. But when there is no sun, the sky was overcast, then also you got these images, the images you got. So, that surprised him, that made him to understand these are not due to X-rays, right. For some reason Becquerel decided to develop his photographic plates anyway. To his surprise, the images were strong and clear, proving that the uranium emitted radiation without an external source of energy such as sun. This is the interesting part. You are expecting the sun's radiation is absorbed by the uranium salts, sulfates of uranium, and they in turn give X-rays, but it is not the case. Even when there is no sun, strong radiation was coming from the uranium salts, which is perplexing. So, that is the discovery of so called radioactivity. So, hence Becquerel had discovered radioactivity in the year 1896. The term radioactivity was actually coined by Marie Curie, who together with her husband Pierre Curie began investigating the phenomenon recently discovered by Becquerel. So, the credit of discovering the radioactivity coming from salts of uranium, this particular thing was discovered by Henry Becquerel, and it was further investigated by Marie Curie and Pierre Curie. The Curies extracted uranium from ore, and to their surprise found that the leftover ore showed more activity than pure uranium. Compared to pure uranium, the left out material had shown more radioactivity, and they concluded that the ore contained other radioactive elements. This led to the discovery of the elements polonium and radium. Just now I told you the word polonium comes from Poland, in the sense that Curie is a Polish woman. So, to give importance to her native country, she named the element as polonium. You know, one of the elements in the periodic table. Radium is again an element in the periodic table. You got Radium Institute in France. She migrated from Poland to France. So, you got polonium and radium. They are the two new elements which are discovered by Curie. It took 4 more years of processing tons of ore. They did nerve wracking, very difficult experiments in those days without taking proper care of the radiation coming from these radioactive materials. They took long years of processing tons of ore to isolate enough of each element to determine their chemical and physical properties. In 1896, the French physicist Becquerel discovered that uranium containing crystals emitted rays that could expose the fog and fog on the photographic plates. That is what we saw. He found these rays originated from changes within the atomic nuclei of the uranium atoms. So, the radioactivity is a phenomenon due to the changes which are taking place inside the nucleus, not outside. We have been discussing about electrons which are outside the nucleus, but the radioactivity, both natural and artificial, they are mainly nuclear processes. He proposed that the uranium atoms were unstable. They emitted particles or energy to become more stable. Until they become stable, they keep on emitting the particles as well as energy, means the gamma radiation. These emissions he called as uranic rays, because of they are coming from uranium. Later the name was changed by Madame Curie. These emissions he called, Henry Becquerel called as uranic rays, because they are coming from uranium. The first woman in France to do graduate work, that is Marie Curie, carried out her doctoral work to determine if other substances emitted uranic rays. Like whatever that Becquerel found from uranium, she tried to find whether other substances also will be emitting such kind of radiations. She discovered that 2 new elements which she later named polonium after her native Poland, and radium which emitted high levels of radioactivity. Marie Curie changed the name of uranic rays, as I told you, to radioactivity or radioactive decay. It is called radioactive decay because of the fact that the parent nucleus, the original nucleus, after giving rise to alpha, beta and gamma radiation, will become a new nucleus. It is called a daughter nucleus. A parent nucleus becomes a daughter nucleus, and again it keeps on emitting radiations unless it becomes stable. From unstable nucleus becomes a stable nucleus. She shared the Nobel Prize, as I told you, with Becquerel and her husband Pierre Curie for discovering radioactivity. Except for H, every atom has protons and neutrons in its nucleus. Hydrogen is the only element you know as but one proton, there are no neutrons. Elements may exist as different isotopes, that also you know. Hydrogen, deuterium. Deuterium means what? Again is hydrogen containing 2 masses inside the nucleus. What are the two masses? One is the proton and the neutron. Okay. Tritium, that means what is 3? 3 refers to the mass number. What if the mass number is 3, you have got H here, hydrogen here, the atomic number is 1 here, right. Atomic number is 1 means 1 negative charge, that will be only 1 positive charge, that will be 1 proton. So, tritium contains 3 masses, means there will be 1 proton and 2 neutrons. Here there will be 1 proton and 1 neutron, okay, which differ only from the number of neutrons indicated by the mass number. That this is the mass number, this is the atomic number. Okay. So, we have got the isotopes are stable. Here they are the isotopes. Some isotopes are unstable and radioactive. Example, these are unstable and radioactive. The unstable radioactive isotopes are called radionuclides. The unstable radioactive isotopes are called radionuclides. The notation or symbols used in nuclear physics is number of protons plus the number of neutrons, that is the mass number. A is the mass number, right. The mass number is denoted by letter A. Number of protons should be equal to the number of electrons, that is the atomic number Z. E is the symbol for the element. So, you have 0 here, that is the mass number, and -1, that is the charge of the electron. You got E here. Proton, you got mass number, you got the plus is the proton is positive charge, electron is negative charge, neutron does not carry any charge, but it has got a mass, right. Neutron has got a mass, it does not carry any charge. The -1 is the charge of the electron, +1 is the charge of the proton, neutron does not carry any charge, hence you have got 0 here. Okay. There is some, okay. The types of radioactivity, you should be knowing that the entire spectrum, the electromagnetic spectrum that you have got consists of X-rays, gamma rays, or the microwaves, and okay, finally what radio waves and so on. So, you start from the high frequency, the cosmic radiation, gamma radiation, X-rays, you got ultraviolet, right, which leads to sunburn, the ultraviolet, right. It may be falling on the human beings, giving rise to sunburn and cancer and so on. The visible light, infrared being used for therapy, microwaves which are used in microwave ovens, you got in the kitchen, you got the microwave oven, and radio frequency, right. So, the low frequency region, the entire electromagnetic spectrum containing the high frequency region and the low frequency region. Now, this we are showing because we are going to talk about the gamma radiation, high energy gamma radiation. Okay. So, what are alpha particles? Alpha particles are nothing but it is nothing but the nucleus of helium. You know hydrogen, you look at the periodic table, you have got hydrogen, and the element with atomic number 2 is helium. Even though you got the helium atom, the charge is 2, the mass will be 4, there will be 2 protons and 2 neutrons. What is the atomic number of helium? It is 2. That means it has 2 electrons. To balance the 2 negative charge electrons, there should be 2 positively charged particles, namely 2 protons. Inside the nucleus there will be 2 protons and 2 neutrons also. So, the mass number of helium will be 4. Its atomic number is 2. That means, helium atom will be having 2 electrons and 2 protons and 2 neutrons. The important point is this 4 is important, right. That is the one that is a so called alpha particle. What is alpha particle? It is nothing but the nucleus of the helium atom. The nucleus of the helium atom contains what? The nucleus contains 2 protons and 2 neutrons. So, an alpha particle is one which contains 2 protons and 2 neutrons, or in other words, it is the nucleus of the helium atom, which are massive than any other particle that prevents them to travel to a great distance. It will not be traveling through greater distances because the mass is heavy. They cannot penetrate the skin under small exposure. However, a severe skin burn may result by enough exposure. A helium nucleus that is designated by this kind of thing, it is alpha particle having the atomic number 2, that is the 2 electrons and 2 protons, right. The mass number, the you got the number at the top, that is 4, that is a mass number, that means 2 protons and 2 neutrons. So, this is the helium nucleus, right, without electrons, that is the so called alpha particle. Positive charge, largest particle emitted by radioactive nuclei has the highest charge. So, how do you get the alpha emission? As was done by Henry Becquerel, what he did was he observed this kind of radiation from uranium atom, that made him to call them as uranic rays. So, you got uranium, what is the mass number? It is 238, right. The mass number, what is mass number? The number of protons plus the number of neutrons. How many protons should be here? Tell me how many protons should be there here, because the atom to be stable, what is 92? That is atomic number. What is atomic number? The number of electrons. The number of electrons and the number of protons should be equal in any atom, because the number of negative charges carried by electrons should be equal to the number of positive charges which will be carried by the protons. So, this 92 refers to the atomic number. So, there are 92 electrons. So, that should be 92 protons. So, how many neutrons are there? If the mass number is 238, what is mass number? The number of protons plus the number of neutrons. Number of protons should be 92, because the atom to be stable, the number of electrons and number of protons should be same. So, there should be 92 protons here. So, 238 minus 92 will give you what? Will give you the number of neutrons. 238 is the mass number. Mass number is nothing but the mass of the protons and the mass of the neutrons. You have got 92 electrons. So, there should be 92 protons. 238 minus 92 will give you number of neutrons. It is unstable, it gives rise to alpha particle plus the uranium atom here. So, you will have 238 uranium goes to 234 thorium plus the alpha particle. Uranium giving rise to what? Uranium giving rise, you see the alpha particle here, right. The alpha particle comes here. So, the uranium atom gets reduced to from 238, because 4 has come here, that is alpha, the mass of the alpha particle. So, 234 is here, right. You should remember 238 here, and this becomes 234. The mass has been reduced by 4, that is carried by the alpha particle. The charge has been reduced by 2, because the 2 protons are contained here, right. Therefore, from 92 the number of protons will become 90, because 2 protons will be contained here along with 2 neutrons. This is the nuclear reaction that is taking place. So, in this process the alpha particle will be coming out. Okay. This is the alpha decay, how the alpha particle is coming from the nuclear radiation. And let me now pass on to the summary session of this lecture. Radioactivity is due to the emission of products which arise from unstable nuclei. There are 3 kinds of products which are emitted. Their characteristics can be understood from the nature of the deflections experienced by them due to an applied magnetic field. The examples of the reactions are discussed. The questions are the following: what is natural radioactivity? Mention the products coming out. Why does it occur? How are their characteristics understood? The last question being, give examples for each nuclear reactions. With this we come to the end of the lecture. The remaining things which we have to discuss with regard to the beta particles and gamma radiations will be taken up in the next lecture. Thank you.